Okay, hypothesis is a potential answer to the question we are looking at in our experiment. Now, in this class, all of your hypotheses will be formatted, I think blank, or I think blank because blank. Okay. You might not always have an explanation that because in there, but sometimes we will, okay? Now, the hypothesis is kind of just what you think is going to happen based on what you know right now, okay? And I want to tell you that a hypothesis is not an educated guess, right? That is a term that we use in elementary school, okay? It is educated guess, but a hypothesis should not be a guess. Okay? We are now old enough where we have some background knowledge on the natural world, okay? And our hypotheses aren't a guess, okay? Potential answer to the question. Okay, now the experiment is going to test your hypothesis. It's important that you know these different parts of an experiment, okay? You're gonna see this throughout your science career in high school. These are important things to know, so you might as well get them down now. Okay, so the independent variable is the part of our experiment that we change on purpose. Okay. And we'll go over some examples of this. The dependent variable is the part of the experiment that we measure at the end. Okay. It's gonna give us some sort of data, numbers. A constant is something in the experiment that needs to stay the same throughout the experiment. Everything in your experiments should be constant except for your IV. Your independent variable is the only thing we change. So if I'm looking to see how water affects plant growth, I might give plants different amounts of water. Okay, I change that, but the amount of sunlight is going to stay the same. The amount of soil is going to stay the same. The type of plant is going to stay the same. Okay? Now, a control group is a group that does not get the independent variable changed. Or you could say they get no treatment. So in my example, technically, if I was changing the amount of water, we would have a plant that doesn't get water. Now that doesn't really make a lot of sense, or you might have a standard of this plant gets the normal, whatever is considered a normal amount of water. And that could also be a control group. So there are a couple different ways to set that up. Okay, now this one is looking at how does amount of fertilizer affect lettuce growth, okay? So let's take a look. The independent variable. What is something that we would change based on this question? What would we as the experimenter change? Okay. Oop. Okay, so here's an example. How does the amount of fertilizer affect lettuce growth? Now, let's try to identify the independent variable. The independent variable is the thing that I change as the experimenter. What could we change? The amount of fertilizer, okay? I can give lettuce plants different amounts of fertilizer. Now, what would be my dependent variable, or the thing that I would measure at the end of my experiment? I could measure the lettuce growth in centimeters, okay? I'm going to see how the amount of fertilizer affects the lettuce growth. What are some things we would want to keep constant? So we know that we are changing the fertilizer, so that cannot be a constant. everything else would need to stay the same. All of the plants would need to get the same amount of sunlight, the same amount of water, and be at the same temperature. That way we will know if it is the amount of fertilizer that makes a change in the growth. Okay, think about it. What would be a control group? Now, a control group gets no treatment or no independent variable. So we would have a group that does not get any fertilizer, and that would be our control group for us to really know, does the fertilizer affect the growth? Okay, so next up, after you do the experiment, you need to collect your data. There's a few different ways we can collect data. It might be in a data table like this. We might do a graph, a line graph or a bar graph, okay? Your data is collected based on your observations, using tools, or using your senses, okay? And lastly, we need to analyze our data and make conclusions. We're going to compare the results that we got to our hypothesis. It's important to know that if the results match your hypothesis, you will support it. We're not going to say my hypothesis is true, or it's correct, or it's factual, okay? We're going to say support. Because in science, things are always changing, and we don't want to say that something is fact. We want to say we support it, right? Because we are just one person, a few people doing an experiment. Okay. We will reject our hypothesis if the hypothesis and results do not match. At the very end, we will probably do a CER to make a conclusion and research a scientific explanation or a scientific reason for the results. All right, I hope this was helpful.